We'll start with Alvin. Anna. Anna. Bella. Flavio. Flavio, by the way, that you recommended the student who's been joining us. So
Good.
Yeah.
Excellent. Good to hear.
He's not on today because he's got a conflict of class, but
Okay.
yeah, thank you. Jack.
Hi, I'm here. How's everybody today?
Lovely. How are you doing? Hey there.
Good, good. I don't have anything really to report, but I just want to say it's kind of hard to hear you guys.
Okay. If we speak up, does it help?
Yep, that's better.
Okay, great. Annette? John?
Yes. Well,
Sorry,
long ago.
Jonathan Evans. Be up next. Rob Mayer? Ron Miller? Ryan Morfin? Sean?
Here.
Todd? Michael? Sheldon?
Here.
Thank you. And Scott. Great. All righty. As always, thank you so much for joining us, both online and in person. I really appreciate your engagement as always. This is a new meeting room, so for folks who are here today, if you need to go to the bathroom at any point, just go straight through those doors, and there's a door to your right, and you'll be able to get in. You don't need a badge in or anything, you just get in to go to the bathroom.
You'll need a badge to get back into this room.
Yes, we'll have one of our teammates here,
Oh.
me and Tage, to help you in.
Okay.
And, all right, I'm just gonna go through the agenda. Before I do that, any other questions, concerns? Is need space, so do let us know. Do raise a hand if you have any questions at any point. Okay. So our agenda today, lovely agenda. We're gonna do a quick report out of the peer review that we talked about last time and let you know about the results that came out of that. I'm gonna give you a status update on the cost savings efforts that we've done this far. And then we're gonna do construction updates as well, give you a little bit about the West Portal and some other things that we've been up to. And then we'll end with path forward and next steps. Questions before we move forward? All right, for folks online, at any point, if you have a question, just use the raise hand function and then I'll be able to unmute you. If you do want to ask a question, but you don't want to speak or you can't speak, then just type it into the chat and then I'll be able to read that into the room, okay? All right, let's go ahead and get this meeting started. I'm gonna pass it over to Erica to report out on our peer review.
All right. Before we do that, Clara Wilson, our Director of Construction, is joining us today. She hasn't been in the community working group before, so I wanted to introduce her. Glad you're here. She's going to be giving us a construction update today. All right. There we go. We have been working hard on cost savings over the last year, and we've collaborated with FTA on attendees and hosted a peer review to look at the feasibility, constructability, packaging, and delivery methods of our project moving forward to enable us to advance on our path forward on the project. We hosted that peer review on August 20th. The peer panel was made up of representatives from Sound Transit in Seattle and LA Metro, who worked on similar projects, large projects as ours, and have gone through similar challenges as we have been experiencing. Other attendees at the meeting included members of the Federal Transit Administration, their project management oversight consultant, our partners at BART, as well as Gall Zeidler, who's the subject matter expert for the oversight committee. We had a day and a half with them where we took them out to the construction site and a tour of the alignments, and then walked around downtown and then spent the next day in the room, as you see in the picture at the bottom, going through all the technical details of the project. We provided a bunch of materials in advance, and so they came prepared, and we had a lot of great discussion. So some of the summary of their input of a report out here is that, you know, we're evaluating two different scenarios. Scenario one being the large 53-foot diameter tunnel for the entire alignment, And scenario 1A being the concurrent tunneling option with the smaller tunnel from the east. So they really thought that scenario 1 is the optimal path forward, which is what we were thinking as well. From constructability, feasibility, offers fewer risks, and it doesn't have any additional costs. And they recommended that we continue looking at our cost estimates to reflect the evolving market conditions, and to break up our contract packages into smaller packages to reduce integration risk and improve interest, as well as including clear provisions for systems. There was a lot of discussion about systems integration and risk related to an owner-supplied tunnel boring machine. In addition, they concurred and stated that a strong working relationship between VTA and BART is critical, which we agree with rather. And we'll continue to work and foster that relationship, and to continue the project momentum that we have underway with the construction out there on the site. So this update, there will be a deeper dive into the peer review at a board workshop we're having next Friday, the 17th. So you can circle back for more details there. In addition, the actual report is posted on our website. And so if you're interested in looking at the actual report, we can send that link out as well. So now I want to touch briefly on cost savings status and where we are there. The last few kind of remaining items from when we last met in August and walked through and kind of where we were landing are there's some systems work we're still working on with BART. The refinement of the downtown station, moving the station infrastructure facilities above grade, coordinating and working with BART, partnering with BART on the yard, and then making the decision on the configuration we move forward with, whether it's the single 53-foot diameter tunnel or the concurrent tunneling option. So a reminder of generally what the station refinements have been. We moved the station infrastructure facilities above grade at all 3 of the underground stations. We relocated and made station infrastructure facilities more efficient to reduce their footprint. For the underground stations, kind of aligned the buildings above the circular drum below ground. At Santa Clara station in particular, there's some change of use of materials. There was a slight reduction in the size of the roof and some structural efficiencies of the roof of the station entrance building. And then we were able to remove in the parking garage and replace the parking garages with surface parking, same number of parking spaces, but in a surface condition at both 28th Street as well as at Santa Clara. And being able to make that change at Santa Clara, or rather, we have the ability to make the change at Santa Clara because of the work that we've been doing with BART on the yard layout. So we were able to free up space to have that space available. Okay, so at Santa Clara, we've discussed the facade through a significant effort that we went through. This is the time for when we'll be discussing that for the downtown station that's going through some changes. And wanted to flag, knowing that now there's, with the refinement, the shape of the station infrastructure facilities at Santa Clara station has slightly shifted. So we'll spend some time in the second half of next year looking at what the facade of that could look like, what the treatment would be. And then same time frame for looking at, again, at the landscaping and the hardscaping kind of plaza area around the frontage and the station infrastructure facilities for Santa Clara. The image on the screen here is an example of a plaza adjacent to a downtown Berkeley event structure. The images are meant to be illustrative to help you understand the types of things that we'll be discussing, and not in any means something that we're recommending. All right, so I'm going to walk through a little bit more in detail the scenario 1A, the concurrent tunneling. But before I get there, I wanted to touch on why the configuration matters, why we're trying to make this decision now. The configuration is tied, it dictates how we advance in our design for the tunnel, as well as there's changes at the 28th Street station with that option. It dictates our approach to the construction of the tunnel, our ability to stay on schedule and meet our projected revenue service date of 2037, as well as our flexibility provides flexibility to proceed if the FFGA is delayed for some reason. So we have three sources of information that are feeding into this decision. We have advice from the independent peer review that occurred. We have the work that our project team has been completing that we've been reporting out to you all on. And then we've been coordinating and having several meetings with Gala Zeidler, the oversight committee's subject matter expert.
So who makes the final decision? The VTA or?
The BTA, so we are going to get direction from the BTA board, hopefully next Friday at the workshop and special meeting on the direction on the decision on the configuration. So on the screen here, you can see the two configurations. The one single bore large tunnel the entire way for scenario 1, or scenario 1A with the smaller tunnel from the east, meeting east of downtown with the larger tunnel from the west. Some additional considerations that have to be taken into account for scenario 1A that are not in scenario 1 are that if we're launching from the east, we need to build a launch structure at the east portal, and we need to acquire an additional 40-foot diameter tunnel boring machine. The 28th Street station construction would have to be a cut and cover construction versus a just singular shaft for the large bore tunnel. And then we have an additional meetup location and retrieval shaft east of downtown. And there's several considerations that affect the schedule as well. The faster tunneling rate for the smaller tunnel boring machine. But in addition, there's additional startup activities that we haven't started at the east portal that have to occur before we can start construction there. And then now we have the complexity and the time needed to extract both tunnel boring machines just east of the downtown station. So to remind you what the tunnel diameter is, why we need the difference at the 28th Street station on the right, you see the large tunnel with the 22-foot platform that fits within inside the tunnel. And on the left, you see the smaller 40-foot diameter tunnel. And as you can see, the center platform won't fit with both trains within the tunnel. That's why we have to build a box around the tunnel at the stations to construct the station there. The map here shows the east portal location. We would have to turn the retrieval shaft that was there into a launch structure, which is the area in green there. The red outline is our construction staging area, which when you compare it to the large 40 acre facility that we have to work in at the west portal, it's much smaller and more complex to use. So we would need additional staging required, which would require more right of way. We would have more tunnel spoils that we would have to be off hauling at the same time. We would need temporary power for the tunnel boring machine here, and we would also need to acquire an additional tunnel boring machine. Maybe lost the slide, or maybe it's out of order. It didn't make it in. So just to describe the 28th Street station change, there's not a visual that's going to work in my favor here. So with the large 53-foot diameter tunnel, we have the circular station entrance building, and there's a drum that goes straight down with a vertical circulation. So that's the only excavation that would be needed to build the station from above ground for 28th Street. But with the smaller tunnel, then we have to do a cut and cover box that's 700 feet long. So it's a much larger excavation that's needed and costs more money. And then here on the screen, you can see the meetup location would be somewhere between 3rd and 7th Street for one block. And in the bottom picture, you can see it would take up probably like 2/3 of a block would be closed for the amount of space for the meetup shaft and to cut and cover to construct the shaft, and then cover it up for use again, and then to open it up again and extract the pieces of the tunnel boring machine. now I'm gonna walk through the schedule. So at the west portal is structure and preparation is farther advanced. And month 0, when we start tunneling from there, we're not yet able to start at the east portal with the smaller machine. So by the time we're ready 10 months later to launch from the east portal, the large 53-foot diameter machine is already down adjacent to the Deerdon station. And then when the large machine gets to the meetup spot downtown, the smaller machine is only adjacent to the 28th Street station. And then it ends up arriving there at month 25, so 7 months after the larger TBM. So knowing that there's all these additional costs, the only way this scenario would be beneficial to move forward would be if there was schedule savings that would offset those additional costs, which we're not seeing. And just reiterating, this is what the configuration 1 looks like we've been talking about.
Quick question.
Yeah.
What is the, on scenario 1, what is the expected, month finish for that? Cause it looks like it's 25 if we have 2, meeting at the center. You don't, didn't lay out what it would be if you went for just the 53-foot, machine going the entire distance. Are you saying it's similar to basically that?
It's similar.
Okay.
Yes, very similar. Any other questions on this in current tunneling or cost savings before we turn it over to Clara to talk about construction update?
Folks online, if you have any questions, feel free to unmute and ask your question or type it into the chat. All right, no questions for now. All right.
I don't know where the signal is bouncing off of and coming back to. West Portal construction update. So, you all know where the West Portal is, I am sure. It's in Santa Clara and San Jose, at, well, the west end of the project. So that's where we currently have an active construction area on the 40-acre site. And this plan view of the site shows some of the things that we have going on there. And I can walk through them. Do I have a pointer appears on the screen? Okay, cool. The teal area is our launch structure layout with the ramp. Thank you, Nan. The light blue areas are parking, and then the gray area right in between them is the site offices for KST and VTA. We have our construction management team out there. And then we have other facilities, other facilities that will be needed in future, such as the purple box, which will be the area where segments are fabricated and stored, the precast concrete tunnel liner segments, which are needed to line the tunnel or provide the initial support and final support this tunnel. And then the pink area is a muck bin, which is an area where tunnel spoils will be staged prior to off-haul off-site. Yeah. That's anything else here? Yeah, Santa Clara, just forgot to orient all of us. Freeway is on the left, 880, Santa Clara is on the right, and the diagonal line running through the project site indicates the border between San Jose and Santa Clara. A zoom in or an isometric view now of our Caterpillar shaft and ramp. And yes, so the Caterpillar shaft is the area that looks like 3 circles kind of squished together into sections of the Caterpillar, and the tunnel shaped thing coming out in front of that, essentially the bottom left of side of that is where the tunnel will be launched, where the TBM will be launched. And then the entire structure leading up to that is the rest of our ramp, which will serve for future revenue service trains to go down, as well as servicing the tunnel heading during construction. For scale, there's a section called out from the shaft itself, and there's a pickup truck in there, so you can see it's a massive structure. The construction method or the pre-excavation support for this is in-ground slurry wall panels or diaphragm walls, depending on where you come up in construction. And then at the far end on the upper right is sheet piles that have been completed. And then the little cross bracing things are bracing, big steel bracing that is installed and pre-stressed during the course of the excavation. So then a plan view of the cat shaft structure with some colored shapes indicating the specialized panels that are especially massive and especially important for structural capacity. These are, we call them our Y panels. The green ones are installed and complete. And then the ones on the far right that say in progress, actually one of those is installed other than the very top part, which goes in a separate pour, was installed earlier this week. And then the other is being excavated already and is planned to be installed next week. These are really cool, and we have some slides showing you some of the facilitating equipment that is needed to get the rebar, to get them basically just to be a fully reinforced concrete structure. We do have 8 Y panels. They go down over 130 feet, and they comprise almost 6,000 cubic yards of concrete. So they're pretty massive. We brought in a very special crane to install these Y panel rebar cages. It's a Liebherr 11,000, Liebherr LR 11,000. It's really cool. We don't have a photo of a person standing next to the tracks, but we don't have a person on site that is taller than the tracks of this crane. Do
I have
we?
one.
These guys are kind of.
Oh, those guys are up there. Okay, so yeah,
So
you can see, thank you. They're there for
Yeah.
scale. It's really, really big.
I have one at home. Yeah.
Oh, sure. I'm hoping to take this one home later,
Yeah.
so. And we did need 39 trucks to bring in the components of this crane, before it was assembled. There's some dimensions there. It's really cool. It's really big. We did have to work with UPRR to, ensure that everyone would be safe and all the train passengers would be safe. And we have lots of backup plans and safety protocols in place there. So, but it's really neat, and there are definitely a number of folks interested in observing the activities. So then the rebar that goes in for these Y panels is so massive, and we don't want it to bend, and so the KST custom designed and fabricated what they call a tripping frame to basically serve as a spine for the cage, which is assembled on the ground and then tripped up to the vertical position to then move over the excavated panel and go in. And have we gone through in this group, have we gone through like what is a slurry wall panel or a diaphragm wall panel? Okay. So so our cranes go out there and they dig down and they dig a limited footprint. So for example, we've got this plan view with little rectangles that make up a shaft. And so each of those rectangles, gray or white, you can see it kind of is little straight sections going around curves to make a shaft. Those go in one at a time. So the crane actually digs all the way down 133 feet up. Some of them actually go up to 139 feet, some of the other panels at the end of the shaft. And then there's an open hole all the way down, but that doesn't work very well in our soil and groundwater conditions. And so as the hole is progressed downward, a bentonite fluid is installed in the hole. It's filled up with bentonite. Everyone that works around the hole has to have a life jacket on in case they fall in, because it is a fluid, but it is a very specialized fluid. It has the ability to keep the hole open basically through its specific gravity, through its material properties, and also some caking that happens on the perimeter of the hole. So the bentonite can keep the hole open and facilitate safe installation of a structural concrete wall panel for a certain amount of time. After a while, it kind of starts to go a little wonky and you have to redo it. So there's a kind of a clock, there's a time clock. But for some amount of time, which is a short amount of time, small number of days, the bentonite can keep the hole open. And then what the process includes lowering a rebar cage into that bentonite and then having pipes in that rebar cage facilitate the installation of concrete beginning from the bottom of the hole, which is called a TREMI method of installing concrete. Install the concrete in the bottom. As its elevation increases, as you put more and more concrete in, you pump more and more bentonite out. And so essentially you're replacing that whole bentonite, that whole panel with concrete at the end of the day. So in order to do the part of the process that is kind of fantastic for us to watch is the rebar getting lifted and being inserted into that hole. So that's what we've got some sequence information about here. So this tripping frame needs a rebar cage inside, but it was first tested to make sure that it could be lifted and pinned at the bottom and operated in a way that would facilitate the more than 300,000 pound Y panel cages to be installed. So for this shows in cartoon form, you can see some of the planning that KST has done ahead of time for these picks. We do have 2 tripping frames on site so that one can have a rebar cage being prepared in it while the other is installed in the ground at any given time. The whole assembly begins horizontal, as I mentioned, and then begins to be lifted slowly by the crane itself, and then the crane actually has to walk as it's lifting toward the base of the lifting frame. And excuse me, the tripping frame. The lifting frame is a little piece at the top. Oh yeah, it's a little piece at the top that's like, yeah, exactly. She's showing it there. That's the lifting frame, which stays attached to the top in just a minute here. Thank you. That's great. So we're almost vertical. Everything's beautiful. The cage is held together in a number of different ways. There are mechanical couplers inside. There are things going around it. They check it with a magnet before they lift it up to make sure there's no loose pieces. It's pretty cool. And there's actually an engineer who's assigned to count every single bar in that cage. So the quality control is fantastic. It's lifted all the way up and it's lifted vertical, and then it is ready to go in the hole, but the bentonite actually has to be cleaned because as you dig out sandy particles and clayey particles, change the composition of that bentonite, and it needs to be cleaned to facilitate the clean installation of the rebar and the concrete. So it gets cleaned while the tripping frame is sitting upright and waiting until just a few hours before concrete arrives. Okay, so the lifting frame is the part that is attached to the rebar cage. Okay, rebar cage transport. I'm trying to make sense of what it actually happens with all of the text on this slide. So the lifting frame, it remains connected to the rebar cage. That's kind of the key. We still have something connected to the rebar that can move it, essentially. The most of the frame is there to get it to the vertical position, and then just the top part is needed to actually get it in the hole. Okay, now we have a video, but I'm gonna try to start. Okay, there we go.
I do love that it has to walk while doing it.
Yeah.
Also, if you have the chance to, flying into San Jose with that thing up right now is a trip.
Yes, agreed.
How many cranes are out there right now?
We had as many as 17. I think right now we have probably about 13. Yeah. Yeah, and there's somebody who walks to make sure that crane isn't getting too close to the crane platform edges, because there's a tolerance there that they have to keep within. Yeah, it is fun to see. This shot is at night, which is typically when the cage is actually being lowered into the hole. Because that's the most convenient time to start pouring concrete when there's just going to be no traffic to mess with the flow of concrete trucks, because we have a lot of them, is very, very early in the morning. So this goes in the middle of the night. And that was a regular pick. You could see the crane holding that one as blue, which means it's just one of our sort of normal panels. Then at the upper end of the ramp, where we transition to the ground surface, the sheet pile installation has been complete for a bit here, and now the contractor is excavating and bracing this portion of the approach to the TBM launch structure. So what's pictured here is some benched excavation in accordance with their approved plan, and then thank you, the bracing that's going in, being lifted into place prior to being pre-stressed, and some of those are also instrumented to make sure that they're properly stressed. And then here on the left, we can see our typical setup for a normal panel is 3 trucks at a time, and they come and they unload into those funnels, which are connected to the TREMI pipes, which go all the way down to the bottom of the panel. And then those pipes that convey the concrete are pulled out in sections. So as they need to get shorter and shorter, the contractor keeps up with that. There's a rack of them off to the right. Yeah, so that's, well, it's in the left-hand photo, but it's on the right part of the left-hand photo. So yeah, anyway, that's a concrete pour, and it's really cool to see like 3 pull in, they do their thing, they go away, 3 more come. It's really well coordinated on the site. And also, some of the panels have different strengths, and so they have a system on site to identify. The trucks roll in and they get a little ribbon that indicates which panel they're going to make sure that we get the right strength and the right panel, which I'm greatly in appreciation of. The upper right has a photo of the short pour, we call it, just the very end of a panel, the very top end of a panel has to be the rebar has to be pressure washed to make sure it's clean before concrete is installed. And then the bottom right photo is the next cage being fabricated by the iron rod busters, rod busters on the site, they're doing an awesome job. That's Alta Engineering, they're doing a great job. Okay, so I could talk about that all day, but here's the really cool thing, which is TBM. Our TBM, our tunnel boring machine, is a 16.235 meter machine, or 53.5 feet. It is fabricated at the Heron Connect facility in Lahr, Germany, which is down in the south portion of Germany. Actually, it's in Schwanau. Lahr is the town nearby that has a little bit of infrastructure, so there's hotels there. This town is really focused on this factory. You can see the machine is outside because it's actually too large to fit in any of their warehouse or fabrication buildings. When we got to town the last time for the factory acceptance test, they brought a photographer because it's a momentous occasion when you successfully test one of these machines where thousands of hours have gone into fabrication and design. And they asked me what kind of photo I wanted, and I said, I want all the women that work at HK in a photo. So that's what the left-hand photo is. Some of that's who they could get on short notice, but some of those folks actually did work on our machine. Our main bearing test, some of them are in engineering, and so that was really fun for me. The machine on the right, if you've ever seen Ocean's 13, they make it seem like you don't really need a ton of backup facilities for a TBM, or the drill as they call it, which is run by one guy. Turns out it's actually more of an underground factory. I was the person in the theater that was like, it's ridiculous. People with me were like, can you just please stop talking? Suspension of disbelief makes for a better enjoyment of that movie. So what you can see on the right is the tunnel boring machine, the shield, which is this beautiful steel can shaped part, and then the gantries, which are behind it. And the gantries don't need support because they're inside that precast concrete lining. It's already installed by the time a gantry goes by. We might have a couple more shots of the TBM here. Okay, so that's me taking a photo because it's so cool. That's me taking a photo of the hard facing on the cutters. Actually, they have little buttons that are tungsten carbide that are designed to be extra durable in sandy or quartz containing ground. And then that's me and one of the engineers going ahead and going for a ride in the cutter. Not really. We just got in it. It didn't move, but it does rotate. So we had to make sure it was off. Just to demonstrate the scale. And then this overhead view we got from the manufacturer demonstrates just how massive the gantries and the trailing gear are. They are somewhat proportional to the diameter of the machine. They would be longer in a smaller machine actually, because there's just not as much room to get things in there. It is a whole factory in there. There are tanks and pumps for grout, which is essential to make sure that the concrete lining we install is in full contact with the ground. And water for construction and rescue chambers, because the TBM has to operate with a positive face pressure to keep again, our ground is just like dirt and water. And so you can't open a 53.5 foot excavation in that material without doing something to keep it stable. So the TBM exerts a face pressure, and if maintenance of those cutters that I was fascinated by is ever needed, people have to go in and get pressurized like they're doing a dive in a submarine. And so there are rescue chambers for that, or pressure chambers for that. They're also massive. Just every component is so massive. It's really impressive. So you can't see all the layers, but anyway, it's really long and impressive. Okay, path forward. Please ask. All right, folks. Any questions?
That's cool. Yeah, very cool.
Thanks. Yeah. Any questions, comments?
Yeah, it's super cool.
All right, folks online, any questions, comments, reactions?
When do we get the tunnel boring machine?
Pardon?
When do we get the tunnel boring machine?
It's going into storage,
Okay.
a nominal storage period of 18 months, which we may customize depending on when the launch structure is available and when we have our tunneling contractor here and ready to mine.
Perfect.
right, no questions online?
All right, so now I'm gonna walk through our path forward. So we had a schedule last, I guess, last summer to fall timeframe when we were submitting for our entry into New Starts Engineering. And, since we found out we've been in this cost savings mode, we haven't been able to update the timing, and so are debuting the updated timing now. So we have our design milestones along the top where we ended last year with the cost savings concepts being at approximately 15% design or so. We have our construction activities that are happening concurrently with our engagement efforts, which include the addition of the peer review. We have the VTA board decisions to authorize the start of the launch structure. They made the decision to offer MKST. We'll be going forward to get direction on the project configuration, like I mentioned earlier, as well. I've been advancing towards the FFGA and awarding the tunnel package and our FTA milestones of when we're ready to submit those documents. So now I'm going to walk through kind of how they relate together in a little bit more detail. Okay, so we have the decision on the revised configuration, which will allow us to advance the design till it's approximately 60%, right? And by advancing the design, we'll be able to refine our cost estimates then. And we will be able to then pull together our documents for our cost and schedule and budget and configuration, to present those to the board, and then include those in our application of, our full funding grant agreement readiness documents, submitting those to Federal Transit Administration. And once we do that, then we will have a risk workshop with FTA as well as their project management oversight consultant. Thank you. And then we will submit our application at the end of 2026 and anticipate receiving an FFGA mid-year 2027. So these activities, this is how they're all tied to making the decision now to be able to get the FFGA in that time frame, which is also tied to construction, critical activities for construction, which started out with the board approval of starting the launch structure construction, which we started early this year and has been ongoing. And then in addition, the decision about the contractor, as well as the project configuration, and receiving the anticipated full funding grant agreement before we award the tunnel contract to the new tunnel contractor. So that we can then authorize the new contractor to do some early works and to start to advance, because the tunnel launch structure construction will be complete in the first quarter of 2027. So then they'll be able to take over the site and advance that and prepare in order to start tunneling in 2029. There's intricate weaving for the tunnel critical path as well as advancing to the FFGA. Let me pause here to see if anyone has any questions as it relates to that.
Okay, folks online, questions, reactions? All right.
Okay, so then I was going to touch briefly on contract packaging. So before we decided to, VTA made the decision to off-ramp the contractor, there was a contracting task force that was pulled together to look at how the current CP2 contract was made up and what scope was included. And so that was kind of refined and broken down into smaller pieces for that aspect of the project. And so now the contracting team is looking at that for the rest of the areas of the project, taking in the input that we received from the peer review. We'll be working through and be developing a new contracting plan to take to the board by the end of the year. So we'll provide more updates on that, but that's wanted to let you know that's in progress as well. We have been out and about in the community. We had an interim community working group meeting for the downtown group last month to bring them along with the downtown station design. We were at the Parade of Champions event couple weeks ago. We were at Santa Clara City Council earlier this week where we got the approval from Santa Clara to add 2 additional working hours for KST to be able to install those deep Y panels. So that was approved. We had already received San Jose approval, so now we're fully approved and we have ongoing briefings and are working with Santa Clara to get a tour set for some students.
So that, those extra 2 hours, what's the shift now?
So before it was 6 AM to 4 AM,
Mhm.
Monday through Saturday, so 22 hours a day,
Yeah,
6 days
now
a
it's
week.
24.
So now it's 24 hours a day, plus Sundays as needed, but without truck hauling. So for like maintenance, low maintenance activities and things like that on site.
Which helps with the panel where the vet night's gonna go off and we would have to restart altogether.
Mhm.
Like now we don't have to just wait until we know we can get everything in. We can just continue working and basically save the project money and
Yeah.
time. Yeah.
Okay.
Yeah, and since we started night work in June, we've had 0 nighttime noise complaints. So, and when,
That sound wall's been fantastic.
what?
That
Sound wall has been fantastic.
Oh, great.
Yeah.
Yeah, there was one.
Awesome.
I've not heard any complaints, not on wood. I'm not asking, but I haven't heard anything, so.
Yeah, I went
Yeah.
out there around, I want to say it was around 11 midnight-ish one night and just checked along mostly the San Jose side because, Santa Clara's been fine. But, yeah, it was surprising, even with the noise, curtain over, even a couple districts or neighborhoods back, it was really nice. So,
Great feedback.
and that's going to be kept for the station itself too, right?
So that is there for the construction of the launch structure.
Sure.
And then as the program progresses and construction progresses, there's a noise and vibration control plan that continually gets updated based on the new areas of the project that advance. And so we'll determine whether or not additional noise curtains will be needed during that construction. But that is during construction activities. So once the maintenance facility is there, that will not be there
Okay.
when the project opens. I think just a couple things to highlight here. Tomorrow we have a joint VTA BART working committee meeting at the BART headquarters in Oakland. We'll be presenting an update to both our boards there. And then next Friday is the board workshop and special meeting where we're hoping to get some direction on project configuration, and we'll have a deeper dive in the peer review report out and how, as a project, we're addressing and advancing based on the input we received from the peer review, and then have a further discussion on contract packaging. And walk through also this full funding grant agreement timeline, that rainbow schedule that I walked through with you all today. And I think that's what we've got for today. Anyone has any other questions or?
On the, I guess, first third of the presentation, when it comes to the station design and especially, because I've been on a number of the commissions, please reach out to the Cultural Commission when it comes to the area and the station art, just because they have tons and tons of artists that they work with that are in the area and would be a fantastic asset for that, as well as layout in that plaza for maybe public art, that kind of thing. I would also recommend reaching out to the BPAC, Bicycle Pedestrian Advisory Committee. They know everything when it comes to, especially transitioning from BART onto the streets and everything, and make sure that all works well there. Outside of that, it looks like it's going well. I'm glad that you guys got a lot of subject matter experts involved for the smaller tunnel diameter, the 1A versus 1. Because it makes a lot of sense why you'd want to stick with 1 throughout all this. I guess the big question, the one thing that was kind of a worry, is that those downtown San Jose stations, how deep are they going to start? Are they still at the same depth, or did that end up getting raised up a little bit?
For the concurrent tunneling option?
Yeah, for the scenario 1 tunnel, because I know that one of the questions was with cut and cover, those would end up being raised up a little bit higher. They wouldn't have as much of a drop on the escalators to get to them.
Right. So for when you have a large diameter tunnel bored, or I guess maybe you should answer this. When you bore a tunnel, you have to have at least a diameter to a diameter and a half of coverage above the tunnel. right? So that, and then,
Really nice rule of thumb to have at least a diameter of cover, due to the volume of ground loss,
Mhm.
which has advanced significantly over the years and can now be quite limited to, less than 1%.
Wow.
But it's still with a volume with the face as large as we have it, has the potential to affect infrastructure in the area. So we did not raise the elevation because we still have that same potential to affect infrastructure. We need to limit potential settlement.
Okay. So it's still
Exactly.
going to eventually have the same transit time from street to platform level as the one before. Okay.
And the escalator configuration for the underground stations has not changed.
Okay.
So we still have the 2 escalator runs down to the concourse and stairs down to the platform. So there was talk previously about trying to modify that drum and make it a little smaller and reduce or increase the number of runs or escalator runs, but we've kept it with 2.
Okay. Yeah, I was just in London. I know that some of the Elizabeth line tunnels down there are about the same depth. It's a little bit of a distance on the escalator, but it's not too bad. So, cool. That's it for me.
and we've presented updates to the BPAC and engaged with them, multiple times, so.
Appreciate that.
We'll definitely be back again in the future with more updates, but.
Cool.
All right, folks online, any questions, comments? To our members, Jack, Sheldon?
No, thank you very much for the presentation.
Yeah, nothing from me.
Okay, great. All right, well, thank you all so much for your time.
Yeah, great. Thank you.
Thank you all. You have a good rest of your day. If any questions do come up, feel free to
All right.
email me.
I'm good. I'm good. Yeah, thanks for the communications. Yeah, it's going on, I guess,